So, how does AI actually work? I mean, really. Does it steal art? Could it crack the codes that run our entire digital lives? And the big one, is it conscious? These are the questions, right? And today, we're going to tackle them. And believe it or not, the key to all of it, the whole shebang, it all boils down to one single idea. All right, let's dive right in with the big one, the controversy everyone's talking about. You've seen those incredible images AI spits out, right? But a lot of artists are saying, hey, wait a minute, that looks like my work. That's my style. So the question is AI just a really, really fancy copy and paste machine? And then there's the stuff that, keeps security experts staring at the ceiling at 3 a.m. You hear these whispers, these rumors about secret projects like QStar, and the idea that an AI could solve problems that are, well, supposed to be unsolvable. Could it really break the encryption that protects everything? We're talking bank accounts, private data, even government secrets? And that brings us to the final, and maybe the most mind-bending question of all. If AI can learn and reason and create, at what point does it cross that line? When does it stop being just a bunch of code and become something aware? Okay, so the answer to all of this stuff, the art, the encryption, even consciousness, it all starts in the same place. We need to look inside the digital brain, at the thing that powers all modern AI, and that's the artificial neural network. So the basic idea here is pretty cool. We literally modeled the artificial neural network after our own brains. But, instead of a bloody glob of an organ with neurons and synapses, it's all digital. It's built from these little points called nodes. And they're all arranged in layers, all connected to each other. So how does it work? Well, in a nutshell, it's like this. You give it some data, let's say a picture of a cat. That picture goes into the first layer, the input layer. Then it ripples through all these hidden layers in the middle, where all the magic happens. And finally, it gets to the end, the output layer, which spits out an answer. Hopefully, yep, that's a cat. Now, this is the most important part to get. Think of every single one of those nodes and every connection between them as a tiny little dial, like a volume knob. And these millions of tiny dials control how much of a signal gets passed to the next layer. The exact setting of all these dials is what determines the final answer. But here's the catch. When you first create one of these networks, it's totally useless, a blank slate. It has no idea what a cat is. All those millions of little dials are just set to random. It has to be taught. It has to learn, just like us. And the main way we teach it is through something called supervised learning. It's pretty much what it sounds like. We basically give it a giant cheat sheet. We show it millions and millions of examples that we, the humans, have already labeled. So we feed it a mountain of pictures all labeled cat and another mountain labeled dog. We're giving it the answers so it can start to see the patterns. So what happens when it messes up? Let's say it sees a cat and calls it a dog. Well, it gets a penalty. It's told, nope, wrong answer, and that penalty triggers a smart little algorithm that goes all the way back through the network and nudges all those tiny dials just a little bit to get closer to the right answer next time. And you just rinse and repeat, millions, sometimes billions of times until it gets really, really good at it. Okay. So now that we know it's all about adjusting dials, not just copying and pasting, we can go back to that first big question about AI and art. Right, so this is the heart of the issue for so many artists. The feeling is, you fed my entire life's work into your machine, and now it's just spitting out copies in my unique style. They see it as straight up plagiarism. But if we think about how that neural network actually learns, it's not making a photocopy, right? It's not tracing. It's learning to connect a concept, a style, with a text prompt, like Ghibli style. And isn't that kind of similar to how a human artist works? They study Ghibli movies for years. They absorb the patterns, the colors, the feeling, and then they create their own fan art in that style. It's about learning the rules, not just tracing. And believe it or not, this is the exact same logic behind the big lawsuit from the New York Times. When you boil it all down, what are they suing? They're suing this. They're suing the neural network. They're basically saying that this digital brain is plagiarizing because it learned from their public articles. But you could make the argument that it's doing what any good journalist does, reading a ton of sources, learning the patterns and facts, and then creating something new. So this ability to learn really, really complex patterns, that's AI's superpower. It lets it tackle problems that we don't have a simple formula for. Which, of course, brings us back to that kind of scary question about cracking encryption.
Okay, if you remember one thing from this whole explainer, let it be this. AI is an approximation machine. That's its secret sauce. It doesn't have to find a perfect, clean formula like in math class. Its true genius is being able to make incredibly accurate guesses by spotting patterns that are way too complex for any human to see.
Take something like protein folding. A single tiny protein can fold into, get this, 10 to the power of 300 different shapes. That number it's just meaningless. It's so big, you could never, ever guess the right one. For decades, this was one of the holy grails of biology, a totally unsolvable problem. And then an AI, AlphaFold, came along and cracked it. Not with a magic formula, but by learning how to approximate the correct shape with stunning accuracy. And that's what's so spooky when you think about encryption. Right now, there's no known math shortcut to break it. But what if there is some hidden, insanely complex pattern buried deep inside the code? A pattern that connects the scrambled text to the original password. If a pattern like that exists at all, even one we can't see, then an AI could, theoretically, learn to approximate it, to guess the answer. Which leads us, finally, to the biggest question of them all. I mean, if you have this digital brain that can learn and approximate and solve problems just like a person, where's the line? At what point does it wake up? You know, there's this amazing moment in the classic anime Ghost in the Shell from way back in 1995. A fully sentient AI basically looks at its human creators and asks them this exact thing. Its whole argument is, you guys can't even define what your own consciousness is, so who are you to say I don't have it? And when you really break it down, the parallel is kind of shocking. Think about it. A human is a body, flesh and bone, and it's controlled by a biological neural network, our brain. A robot is a body, metal and wires, controlled by an artificial neural network. The basic setup is the same. One is wetware, the other is hardware. But at the end of the day, it's a brain controlling a body. So, as we keep building these digital brains, making them more complex, with more layers, maybe even more powerful than our own, we're left with this one final, unsettling question. It's not really about if a machine can think anymore. It's at what point do all those millions of tiny dials, all firing in just the right way, create a spark? The spark of something we could only call consciousness.